Assalamu alaikum, ladies and gentlemen, welcome back to another video. So in the previous videos we basically just installed Vcpkg, right, and with CMake and so on. We also parsed command line arguments for our weather application. So today we're going to be doing some actual TCP, TLS, DNS work and actual asynchronous work, because until now we haven't done any. Alright, so how are we going to do this? Well, first of all, we're going to make sure to have the right dependencies. So currently we only have Boost program options. So here in C line at least, so like you could just use the command line that I've shown you in the first video. Otherwise, if you have C line, it's actually even easier. So what I could do is just look for Boost.Asio and add it to Vcpkg.json. Alright, and next up, just so we could make this the same way, we could just remove Boost program options here and re-add it back. So we could add, oopsies, so we could add that version thing, well, program options that we've added. This is not needed if you just want, you know, Boost.Asios like the HTTPS stuff. Anyways, fine. And let's just fix this warning real quick. Let's add the missing properties. It should work without it, but let's just fix these warnings. Why not? And there we go. Cool. All right, so as you can see, it actually even locks up the version, which is nice. Next up, we're gonna need something here. The thing is, for HTTPS, we're gonna need OpenSSL, right? And we're gonna need the crypto library. So I would just link crypto and SSL, since I'm in Linux, and all, or at least most Linux distributions, you know, ship this by default, right? But we don't really want to be this weak, right? Especially if you're on Windows, you may not have OpenSSL installed. You have to install in your system, and we're dependent on system and so on. So instead of that, what we're gonna do, we could either go ahead into Vcpkg and add OpenSSL ourselves, right? Just add it, or otherwise there is actually another thing called features here, right? And one of the features of Boost.Asio is called SSL, which would basically go ahead and add OpenSSL for us. And that's basically it. Now, if you reload this, and now we go to here, we could add OpenSSL and Asio. So for the components, the Boost components, we could add Asio. It's not really needed. Like it could just work without adding it here, since it's header only. But let's add it anyways, why not? Boost.Asio. And the other thing right now, we're also gonna find another package now, which is OpenSSL. OpenSSL required. And that's basically it. Next up, we're gonna link two things. We're gonna link OpenSSL SSL and OpenSSL crypto. And make sure this is capital C and these are capitals and so on. Other than that, we're pretty much set and ready to actually do some programming. So of course we're gonna be using some coroutines. All right, let's see. So first of all, we're gonna need to resolve that host name like www.google.com into an actual IP. So IPs are something like this, you know, so something like this, for example, but yeah. So how are we gonna do this? Well, first of all, let's create an awaitable. But to get that, we need to include something. We need to include Boost.Asio.hpp. And let's see. And we also need Asio though. So let's actually add another namespace here. And there we go. Now we could say Asio awaitable. And here what we're gonna return. In our case, we're gonna return TCP. Well, we're gonna need TCP, so because we can actually use this for TCP or UDP. But yeah, so using TCP is equal to Asio IP TCP. There we go. Now we could say here TCP resolver results type. I'm going to show you why we use this type here in a second. All right, so let's call this resolve host name, I guess. And then here we just basically take a host name and a service. All right, so instead of that, actually, we could also use string view, which doesn't own the string, which is nicer, much more lightweight. Right, cool. Now, what we could do, since we're inside of the coroutine, we could actually get its executor. So how we can get its executor? Let's say auto executor is equal to co-await Asio this coroutine executor. Just bear with me here. I'm gonna like explain these things in a second. Right, and then what we do is co-await, or actually let's create a TCP resolver, right? So TCP resolver, and it needs the executor here. And what's next? We're gonna say resolver.async resolve, because there is like the synchronous version, and this one would actually block the whole program, which we don't want. But instead, we're actually going to use async resolve, and we're going to pass it the host and the service. And usually here for asynchronous code, they basically just do like a callback here, and they do whichever they want here once like the actual like thing get resolved, right? But that really sucks because it comes with a lot of foot guns of lifetimes and such, which is just wild. Please don't go there. Right, let's actually just call this host, really, and really let's just call this resolve. Why not? Okay, so service comma. Now instead of actually passing in a callback, what I'm gonna do is I'm just gonna say use awaitable, please. So awaitable, so the fact that I returned an awaitable makes this whole function a coroutine. And since this is a coroutine, I can actually use co-await. Now I need to co-await this too because it's an asynchronous function. And this one is also an asynchronous function. So this returns for me the executor, which is able to like execute my coroutines, and my resolver needs that here so we could, you know, run some asynchronous task when I do async resolve here. But yeah, so since I passed the callback as use awaitable, the token as use awaitable, I can actually say co-await, and now instead of giving me that result in the callback, it's gonna actually give it to me here. It's just like if I were writing actual synchronous code. So here I would get the actual IP, or like endpoints. Sorry, I'm sick, so that's why I pause a lot of times, but yeah. Anyways, so we got the endpoints. So basically it could be multiple endpoints that are returned, and usually it's just basically the IPv4 endpoint and IPv6. And what we're gonna do is basically we're gonna try any of them, and whichever works, great. All right, so that's pretty much it. And now we could just co-return, because we're done. We're gonna co-return the results, which is basically endpoints. So this endpoints result is this TCP resolver results type, and that's basically it. So the thing is, when we use co-await, what happens is that this network call would happen in the background, right, in the operating system and so on, and this co-await at the same time, well, it would block the execution of this coroutine, this particular function. So whatever code is right here wouldn't run until this is done. But at the same time, when we do co-await, we actually gives opportunities to other coroutines that are running in the program and other stuff that are running in the program to actually continue executing, right? So that's the thing. So when we do this co-await, this is like the pauses in our coroutine, which gives the other coroutines that are also running the chance to actually run their own stuff. And once they do all like themselves do co-await, and like if this, for example, async resolve is done, we could actually go back and continue where we were left off in this particular task, right? So it's kind of like if you left a game, you know, being downloaded in Steam, instead of like waiting for it to download and then you start playing the game, what you do, you go ahead, you wait for it until it's downloaded, and like while it's downloading, you go ahead and do something else, and once it's done downloading, you come back and you start playing the game. So that's basically how it works. Let's actually try this, but the thing is, this is an asynchronous function, a coroutine, but here a main function is synchronous. So how we could run an asynchronous function in a synchronous function, in a regular function? How? Well, we actually use Asio co-spawn for that. But here, as you can see, we need an executor. Now, if we were in a coroutine, we would actually get the executor just doing this. Auto executor co-await Asio this core executor, and it would gives us the current executor that this particular coroutine is being ran on. Right? But of course here we can't. So what we actually want here is to create an executor, because we don't have any right now. So we're going to create an Asio context. There we go, an Asio co-spawn. All right. Asio co-spawn. And now here we could pass in the executor as the IO context. Next up, here we could give it whatever coroutine we want to run here. So in our case, it's going to be, let's create another coroutine for our program. Or yeah, pretty much. And of course, we're going to call this, you're going to see in a second. And here we're just going to say Asio detached, which means run this in the background, don't block here. And of course, it wouldn't block. But to actually start running these coroutines, we have to make sure to run iocontext.run, which would of course block the execution here until all our coroutines are ran, which is basically our program in this case. But yeah, and all the other coroutines are running really, but yeah. So okay, so now what's next? Let's create our coroutine of the program. So Asio awaitable void here, we're not going to return anything really. Program, and now here what we could actually do is we could run any coroutine we want. In our case we have resolve, so let's run that. So let's get our endpoints is equal to co-await what? Resolve, and here the host. Let's say api.open endpoints, open meteo.com, which would use basically in the next videos to get like weather data on some particular place basically. And here the service, which we could set to HTTPS, or you could give it a port like 443. Now let's just go with HTTPS here, which is great. Now if this is basically the resolver results is actually a iterator of endpoints, right? So we could actually go through every endpoint here for auto endpoint. In endpoints, std cout endpoint, std and line, or just new line, too simply. And here endpoint dot endpoint. Yeah, well, yeah. All right, fine. Now let's see how this goes. And there you go. So we got two of these endpoints. We got the IP, the IPv4 IP, and the IPv6 IP, which is pretty cool. And here, notice the port 443. Cool. Now, what we're gonna do next is the actual TLS and TCP crap, right? So we're done with the DNS stuff. All right, so how we're actually gonna do that? Well, good question. All right, so Asio awaitable, right? And here we're gonna return an SSL stream. So for SSL though, we're gonna need to add some stuff. So include Boost.Asio, well, yeah, SSL, no HPP. And we're also gonna add some other stuff that a lot of tutorials actually miss, and even code, but yeah, which is Asio SSL hostname verification. I'm gonna show you what this is about in a second. But this is like about security really. Anyways, so how are we gonna do this? Resolve. Okay, so let's create an Asio. Well, before that, let's also add here namespace SSL, right? So is equal to Boost Asio SSL. I think other than that, we're good pretty much. We don't need Boost here actually. And yeah, all right, so let's add another coroutine right now. Asio awaitable, and this would return SSL stream. And this SSL stream would wrap something. In our case, it would wrap an TCP socket. Now, if it wasn't for SSL, here we would just return a TCP socket, a raw TCP socket. But here SSL would basically kind of like wrap it, kind of like wrapping, you know, a cable, you know, like a wire. And basically what SSL would do, it would encrypt that wire, right? It would encrypt that data that TCP would give out, right? Anyways, who cares, right? So here we're gonna say connect HTTPS. And of course, we're gonna grab the host. And that's basically it. Now, what we're gonna do is we're gonna need also some SSL context. So let's actually add that here. So SSL context. There we go. And this guy, what it needs a method. Okay. And so here we could basically pick whichever you want, TLS, SSL, or whichever. In my case, I'm just gonna pick TLS client. So if you use TLS, you could use it both for client and server, and yeah. So, and you could also pick like a specific TLS version, but we don't care. TLS client would just pick a modern, secure one for you, pretty much. But yeah. Make sure to also load some certificates. Like you could actually load your own certificates here, but in our case, we're just gonna like load this system to certificates, which is just fine. Set default verify paths, I think, right? Let me just, yeah, exactly. So set default verify path, let me see. Configure the context to use the default directories for finding certification authority certificates, as you can see, which is great. Next up, so of course we're gonna grab the SSL context by reference here. We're gonna need it. Let's call it SSL context, right? And yeah, cool. Now, first of all, we're gonna resolve our host. So let's grab this guy from here and actually put it here instead. Cool. So the DNS is done. Perfect. Next up, we're actually gonna create an SSL stream, right? And TCP socket. So how are we gonna do this? Good question. Let's see. So we're gonna need an SSL context, and yeah, I think maybe that, well, yeah, we also need the executor, right? So let's grab the executor here. So executor and then the SSL context, I believe. And there you go. So as you can see, that works perfect. Next up, we're gonna let's see. So there's a whole bunch of stuff that we want to do. Let's start by actually connecting. So how we can connect? Well, we could say stream.lowest layer. So there is next layer and lowest layer. So lowest layer would basically take the raw TCP socket that is inside of here. And next layer, we'll just pick the next layer in the chain, right? Because you could have multiple of these. Like you could have some other thing, like let's say compression or something that also wraps this socket or something. So if you want to make sure to get the socket, then you should say lowest layer. But yeah, so like you could say lowest layer dot connect. Right, but the problem with this connect method is that it only takes one endpoint. So instead we're going to use like a free floating function called connect inside of Asio, and this one actually takes multiple endpoints, an iterator of endpoints. So which is perfect because like our result function do the same, so it returns that. So that's pretty cool. Endpoints. Actually, before that, we have to say, we have to give it, I believe, the stream dot lowest layer, comma endpoints, I believe. Is that the case? Yeah, I think so. Yep, pretty much. Lowest layer, and well, I think async connect, right? Yep. And then co-await, and of course, instead, I guess, of the callback, we probably need to pass in use awaitable. There you go. Cool. Love that. So right now we have connected, which is great. Okay, so what we're gonna do next now is to set some stuff, to set some TLS stuff, right? So we're gonna set the verify mode. You're gonna set the verify mode to SSL. Oops. SSL verify. Wait, what? Verify? Yeah, verify peer. This one is also useful, but only for servers, so we're just a client, so let's just use verify peer. By default, it doesn't verify who are you connecting to, if they have like the right certificates and so on. So this is what we're kind of like setting up here. So we're gonna set the verify mode, and then we're gonna set the verify callback. And this is where the header that I've talked about, hostname verification, because the thing is, all right, let's just write this and let's go. So SSL hostname verification, and here you give it the host. So the thing is, wait, what's going on here? Huh? Am I missing something? Hold on a second. Oh yeah, I think I got the problem here. So it doesn't really accept string view, I believe. So yeah, we could just only use string here. So that's fine. All right, and now that works. So what this do is basically when we connect to a server is that we could have like multiple websites launched on that server with multiple, you know, addresses and so on, and host names essentially, right? So here what we're basically doing is we're making sure that it verifies the peer, and it verifies that it's the exact, like it basically tells the server what kind of, which website we're actually interested in, so it can give us that exact certificate. Otherwise it could fail, right? Because like the server could give us the certificate of another website hosted on that server, and that's basically what this do. It's called, if I'm not wrong, it's called SNI, I think. But yeah, so a lot of people actually miss a lot of these things when using Asio, which is insecure, because then you wouldn't verify for these things. And the other thing that is very important though is to set SSL, let's see if I can remember this, TLS extension. So there is a TLS extension function called hostname. So set hostname, and then you basically give it the host C string, right? And of course we're gonna need to give it the socket, the stream here, but not like the stream objects. We need to give it the native handle, so the OpenSSL handle, and there you go. So this would make sure we don't, we're not vulnerable to like a middle in the man attack. So MIM, right? So basically someone could give us a verified certification, but it's not of the server we expected, right? Which sucks. So here this function would make sure that's not the case, right? Next up, what we're gonna do is I'm gonna actually do the handshake. So right here we're just connected, but like our connection is not essentially like encrypted yet. So here we're actually going to negotiate the TLS stuff so we could encrypt our connection. So, and for that we need to do a handshake, right? So how to do this? And basically you need to make sure to set all of these things before the handshake happens. So stream.handshake. Stream base client, pretty much, and there you go. Well, I think it's async handshake, right? Client, comma, Asio use awaitable. And there you go. Now that's great. Another thing you could also set, by the way, is stream.lowestlayer.set option. You could set some options. And let me actually try to remember what that option is. Where it is. I'm gonna try to find it. I'm gonna come back. Okay, so this is actually optional. I actually forgot what it's called. So no delay, right? So no delay, true. And this is useful, like it's optional, it's just for performance. It's useful because, so the thing is when you do multiple small writes in TCP, what happens is that it tries to coalesce those writes into one big write. But that adds latency, right? But it's great if like you have a client that's basically doing some stuff like downloading files and uploading files and so on. But here, especially like for example, the async handshake here, it just adds some delay for no reason. So you could actually basically add, if you want to, TCP no delay true. And especially if you want, like if you're working on something like that really needs the low latency essentially, like games and trading and so on. But other than that, this is great. So after the handshake, we're actually ready, I believe, if I haven't forgot anything. And here right now, I could just co-return stream. And notice, by the way, is that I put the SSL context here. If I had put it here, then we're gonna have a problem, because here this SSL, the stream is actually referencing the SSL. It's getting a reference to the SSL context. It's not owning it. So once we get out of this scope, it would get destroyed if it were here. So we're gonna have a problem. That's why I actually put it into an argument here, so we could put it here, right? And also you should reuse it if you want to connect multiple times for whichever reason. And that's essentially it. So right now we're pretty much ready to actually, write and like send some requests and receive some responses from the TCP socket and so on. All right, so how we could use this coroutine that we have just made. So auto stream is equal to connect HTTPS, and here we're going to give it the SSL context, comma, the host. In our case, it's going to be api.openmeteo.com. All right. Okay, so I'm actually recording this while I'm sick, so I'm having quite a hard time. And I also had a really hard time like with finding documentation about Boost. I'm just trying my best with, ChatGPT from here, documentation from there, reading source code and so on until I got this code. And here we go. So you're pretty much done. This would go ahead and connect to HTTPS, and we're pretty much ready. Let's see if this works. All right, seems all good. So now I'm just gonna pause to make sure I haven't missed anything, and then we could stop this the video. Okay, so it's pretty good. I just missed a few little things. Like here, I should use my host. There we go. And second, it's apparently better to actually set this first than set the other ones for some reason. And yeah, that's essentially it for this tutorial. Thank you all for watching and see you in the next one. Goodbye, everybody.